Hello everyone, we're Team SmartViz. We're here presenting to you our junior design project. We have 6 members in our team. I'm Bill.
I'm Paul.
I'm David.
I'm Catherine.
I'm Ziyu.
I'm Ting.
Our project is about manufacturer instrument recognition. And essentially, we're building a mobile application on smartphone platforms such as iOS and Android. And in the end, the application is able to recognize different screw types and thread sizes. We're working with a company called Fluid Technologies. CFT supplies market-leading equipment for all major manufacturing industry sectors. This includes aerospace, consumer goods, automotive repair and refinishing, anywhere. In fact, a coating material that needs to be applied to a surface. Our client contact is Jennifer Alinga. She's a mechanical engineer currently working at CFT. Now, I'm going to hand over to my teammate. They're going to talk about this project in more detail.
So what essentially is our client's problem? Our clients, like other mechanical industries, are dealing with screws on a daily basis. They have screws on their machines and also on their products. So they often come across a problem where they need to identify the thread type and thread size of a specific screw. And in our user research, we found this is actually a very time-consuming process. The only way for them to carry out this task right now is to use a screw checker, and they need to manually put the screw in the hole to see if it actually fits, therefore to identify the size, the thread size and thread type of the screw. And this can take, on average, 10 to 15 minutes to do. This is a huge amount of time our clients cannot really afford to waste. We decided to come up with a solution where we're proposing an Android and iOS mobile application where we can let a user identify the screw by image recognition. So essentially, our user just needs to use their phone, take a picture, and our application will identify the screw and return a mobile type. Also return the purchasing link, so our clients can purchase the screw directly from our application. And our application is similar to Amazon Pathfinder, which is an application by Amazon to identify a specific product from the image and then to purchase the product from Amazon website. However, our solution is still pretty different from Amazon Pathfinder in that we are more specifically focused on the screws and we have better accuracy. And we're also returning the link to McMasterCard, which is a much more comprehensive database and purchasing website than Amazon regarding screws. And I will hand it over to David to talk more about user research.
So starting off with our intended users, we probably have 2 categories of users that we would like to target this application towards. So the first one is mechanical field service engineers at Carlisle Fluid Technologies. After all, this is who our client is, so we're primarily developing this application for them. And in addition, we plan to make this application public, so independent homeowners or contractors from other companies can also use this application to guide their work in screw identification. Alright, so to kind of get a general sense of how we want to develop the application, we use a survey and distributed it among Carlisle Fluid Technology employees. And based on the results from the user research, we got 3 results. 3 important ones especially. So the first one is the background setting. So in particular, this application will be used in an environment where there will be lots of different tools and equipment and machinery, such as engines, turbines, screws, screwdrivers, etc., other screws, etc. So we need to find a way to smartly identify what the client would like to identify within the application. And afterwards, we also figured out for the mobile operating system that most work phones at Carlisle Fluid Technologies are iPhones. And as a result, we plan to prioritize iOS development, and Android will become our stretch goal. And lastly, there's also email access. Our clients have voiced their concerns about having access to their emails through the application, primarily so they can track their servicing history and also to kind of have a way to network with other employees with regards to figuring out how the application works and various other techniques of communication. And with that, I'll hand it off to Catherine, who will talk about physical prototype.
With what we learned from user research and studies, we went ahead and designed our initial paper prototype, which includes 3 main features: the user account system, screw identification, and the return purchase link URL. So we'll explain our design choices in the next slides more in detail. So for the first feature is a user account system. Users can either log in as a return user or register as a first-time user to our system. They can also change their personal information, for example, to upload a personal profile picture so they feel more connected to the system that we designed. Moreover, as we mentioned before, we hope that users can search their past histories, so we designed a page where users can filter based on dates and screw types, and then all the pictures that match the criteria will come up to the screen, and when users click on one of the photos, they will be able to see the detailed information one more time.
I am going to talk about our second main feature, which is screw identification and recognition. Basically, the user will be given 2 options. One is to take photo real time, and another is to allow the system to access the user's photo album to see the screws. And then the user will be given extra function of editing the photos, which will become our stretch goal and will be implemented next semester. Then, once the photo is being processed by the system will display the detailed information of the screw, and which is our next main feature. Our last main feature is to return purchase link URL. Basically, the application will return the purchase link of the McMaster-Carr website of the screw, and then a detailed information of the screw will be displayed on the same page for the user to take a closer look at the screw they want to identify.
And now I will also show you a video demonstration of how our application is intended to work.
Alright, so starting off with our demo, we have our login screen pulled up right now. For the purpose of this demo, we're just going to simply log in. So there's 4 main functionalities the user sees once they log into the application. The first is scan screw, the second is my account, third is photo album, and fourth is my history. So the main feature of this application is scanning a screw and obtaining information, so we'll go over that really quickly. So once clicked, the scan screw module will pull up this camera, and then the client can take a picture of the screw. And once that's done, the screw should be processed. And after processing is done, a list of parameters comes up. So head type, head diameter, length, and any other information that could be useful to the clients. And at the very bottom, we also have a purchasing link, which once clicked, will bring one up to the McMaster-Carr website, where one can finally finalize purchase of a screw. And going back, there's also a photo album, where past photos can also be loaded for processing. And for example here, and once again we have the same kind of design, same kind of flow with the photo album approach. There's also my account, where one can edit their settings and change their headshot. And there's also a history, which shows a list of services that were done with particular screws and specific screws. And that overall concludes our demonstration, and I'll leave it to Tim to finish off with some of the lessons we learned over this semester.
Thanks, David, for the demo class, and I'm going to talk about the lessons we learned from this class. First, client communication is key to success on any project. Since this is our first time to work with a client on a specific project, we took it very seriously. Every time before we submit our assignments, we would send them to our client and got feedback from her to see if it meets her requirements. Also, we could know what improvements or changes we can make on our project based on her feedbacks. Second, weekly meeting is very significant for a team. At the beginning of this semester, we signed a document called called team charter. We do that. We must meet at least once every week to work on our group assignment. In every meeting, we will take turn to record the meeting minutes, which describe what we did during this meeting. Since we have a fixed time every week to work on the group assignments, we could finish it on time. Also, we will make sure that we have time to commit with our clients or professors about our projects so that we can have some correct judgments on our project, which can largely increase our efficiency and quality of our works. This is what we learn from this class.
Thank you very much for your time. If you have any questions, feel free to contact us.